Today on the BLIC method, we're going to be learning about how to graph what is one of our parent functions, and this specifically is the absolute value function. Y equals the absolute value of x. Now you will need some pre-skills to this. Before you graph that type of function or equation, you need to know how to solve an absolute value problem. So I'm going to do a very quick little review on what absolute values bars really mean. So if I were to take the absolute value of 6 minus 8, okay, you would have worked this out in previous years, and you would have said 6 minus 8 is going to give you a negative 2. Now, what an absolute value bar really truly means is how far, what would be the distance on a number line that value is to 0. Okay, so now if you think about distance, you would never say, oh, just because if I was walking forward, right, I walked 3 feet forward, okay, but if I was walking backwards, you're not going to say he walked negative 3 feet. The distance I traveled is still a positive distance. Distance cannot be negative. There's no such thing as a negative distance. So now when we're talking about the value of negative 2 on a number line, we would have 2 to the right, negative 2 to the left, but the distance you'd have to travel from one to the other would be 2 if you're going to positive, and it would be a positive 2 distance even if you were going to the negative side. Your distance is still a positive value. So that's really what absolute value means. It's distance from 0. So the fact of the matter is no matter what the value on the inside is, it will always come out as a positive value. So the absolute value of 6 minus 8 comes out to the absolute value of negative 2, but those absolute value bars, just to make things very simple, it's going to change negative values into positive values. If the value was already positive inside the bars, such as the absolute value of 2, absolutely nothing's going to change. It's going to stay a 2. So that's your quick review on what absolute value bars will do. It's just going to change negative values into positive values. Don't overthink it. Just stick with that. Okay, but now we got to graph it, and we got to ask ourselves, what's that going to do to an equation if we put absolute value bars around the x? Okay, the best way to really make this graph for the very first time would be to make a table. Okay, so this is going to create what we call a parent function. Now, when we say a parent function, it doesn't mean we're going to be it's not telling you to go to bed early or anything like that. It's just a very simple, most basic of functions. For example, let me give you a really quick parent function to y equals mx plus b. We're not going to have any kind of crazy intercept. We're not going to have any kind of crazy slope. It's just going to be a very basic slope of 1 over 1. So we just show that as an x. And then plus 0 starting in the very center or the origin. Nothing crazy about this. This is what we call a parent function to a linear equation. And that would come out looking like this. We'd be going up 1 over 1, up 1 over 1, up 1 over 1. We're not doing anything crazy like 4 over 1 or 1/4. It's just very basic. That would be a 1, which is 1 over 1. That's why our rise and run is what it is. And we're crossing at the origin, 0. There's no need to say plus 0. Okay, so your basic parent function of a line is y equals x. Now notice we're taking that, and all we're doing is putting absolute value bars around it. We can do a lot of things to this equation where I add, subtract, both inside or outside of the bars. But right now, we're just going to stick to the basics, the parent. Okay, let's get to it. All right, I would create a table. Anytime that I'm not sure of what it's going to turn out looking like, which if you watch videos that I'm going to be posting here in the near future, you should have an idea of what these will all end up looking like when we're done. But for right now, let's make a table. Table of values, our x and our y values. Let's list out some numbers, and let's see through math what that image would look like. Okay, so on a coordinate grid, if I were to pick numbers, I'm going to pick both positive and negatives. Let's start with negative 3, negative 2, negative 1, 0, 1, 2, and I was just off. I wanted to make it even. Let's go one more down there. 3. We're going to figure out what each of those y values would turn into if we plug those numbers in. Now, when it's a parent function, very basic function like this, it shouldn't be too tricky. I want you to put a negative 3 right there and replace the x value with negative 3. I'd write that over here. Y equals the absolute value of negative 3. And with that quick review that I just gave you, you should know that the absolute value of -3 is, you better believe it, 3. So that would be your solution for y. That's what y would come out to. Okay, now if you did that for each one, I don't think I need to write down each one of these. I think we can answer them mentally. Take a -2, put it in for x. The absolute value of -2 is 2. The absolute value of -1 is 1. 0 is not tricky. There's no trick to it. 0 is going to stay 0. Now we go into our positives. If I put a positive number in with absolute value bars around it, does anything change at all? No, it stays the same. It's a piece of cake. 1, 2, and 3. Okay, so we now have our coordinates is basically what a table of values is giving us. It's giving us a x and a y. It's giving us an x and a y. Now, if you needed to list each one of these out, by all means do so. I personally think most of my students and you guys online on the other side of this screen could just look at this and graph ready to go. But here's a list of coordinates. I'll just finish it up since I started it. And if I plot those points, I will know exactly what my absolute value parent function will end up looking like. So -3, 3 is going to be up here. -2, 2. Going to be right there. 1, -1, 1. Back 1, up 1. 0, 0, the origin. 1, 1. 2, 2. 3, 3. And just like that, we have our graph. I'll step to the side over here to make these lines. Now I draw these arrows because my graph continues on. It's just not what I showed. It's going to continue on. Now what you created was a V. Okay, this is the shape that you will see anytime you are graphing something with absolute value bars on it. So your go-to, your thing that you need to know, and this is just through memorization and working with it long enough, okay, you have to know that if you are ever graphed, or you're ever asked, to graph an absolute value bar function or equation, that your image on the graph should show a V. Okay, it can be flipped upside down. It could be done, a number of things can be done to it. And I'm not going to get into all of that right now. But right now your basic function, parent function, is this V, where you're going to be going up 1 over 1, up 1 over 1, up 1 over 1, back 1 over 1, back 1 over 1. Okay? You make that V, and this is your parent function. So once you know that, you can now watch my future videos that I'll be posting where I'm going to be showing you how we're going to transform that image. Okay, it's not always going to be stuck right there in the middle going up 1 over 1, up 1 over 1, up 1 over 1. Okay, it will get much trickier, and there's a lot of rules to it. There's 3 things that you will need to know. But if you just break it down into 3 different things, you should be able to know ahead of time exactly where that V is going to move to and what it will look like. Okay, so please tune into those other videos so that you can have stronger knowledge of absolute value functions. Here you now know your parent function, and we can go from there. Good luck on your upcoming test.